Troubleshooting tips for ground fault circuit interrupter, or GFCI, tripping issue involves a systematic approach to identify the root cause. Let's break down the possible areas to investigate. Firstly, let's discuss electrical wiring. Inspect the wiring. Ensure that all wire connections and all junction boxes at the panel and at the spot control panel are secure and free of damage. A loose connection can create resistance, leading to heat and potential ground faults. Secondly, test wire continuity. Use a multimeter to check the continuity of the wires from the panel to the spot control panel. This will help identify any breaks or shorts in the wiring. A good connection should have very low resistance, close to 0 ohms. A high resistance reading indicates a problem. Thirdly, check for ground faults. Utilize a ground fault circuit tester to detect any ground faults along the wiring. A ground fault occurs when current leaks from a hot wire to ground. This is what the GFCI is designed to detect. Next, we move on to the GFCI breaker. One possible cause is a faulty GFCI breaker. The breaker may be tripping prematurely. Replacing it with a new one may resolve the issue. GFCI breakers can fail over time. It is worth trying a replacement. Next, test the GFCI breaker. Use a GFCI tester to check if the breaker is functioning properly. These testers simulate a ground fault and verify that the breaker trips as expected. Now let's talk about the spot control panel. Firstly, inspect the spot control panel. Examine the panel for any signs of damage or loose connections. Water intrusion or physical damage can cause electrical problems. Secondly, test the heating element. Disconnect the heating element and measure its resistance. Replace it if the resistance is out of specification. A heating element with low resistance can draw excessive current. Thirdly, check for water leaks. Inspect the spot for any leaks that could be causing moisture to enter the control panel. Moisture is a common cause of electrical faults. In addition to the above, here are some additional considerations. Firstly, check the spot filter. A clogged filter can restrict water flow, causing the heating element to overheat and trip the GFCI. Secondly, verify proper water level. Ensure that the spot has an adequate water level to prevent the heating element from overheating. Thirdly, inspect the spot cover. A damaged or poorly fitted spot cover can allow moisture to enter the control panel or wiring. Now let's discuss specific areas in the installation that may cause problems. Firstly, the junction boxes. Ensure that the junction boxes are properly bonded and have sufficient space for wire connections. Cramped or poorly bonded junction boxes can create opportunities for shorts. Secondly, the cord cap connection. Check that the cord cap is securely connected to the spot control panel. A loose connection can cause arcing and heat. Thirdly, the electrical metallic tubing or EMT conduit. Verify that the EMT conduit is properly grounded and not causing any ground loop issues. Ground loops can cause unwanted current flow and nuisance tripping. Fourthly, the receptacle. Inspect the receptacle for any loose connections or damage. Loose connections can lead to arcing and heat. Finally, the cord itself. Ensure that the sew cord is in good condition and free of any damage or splices. Damage to the cord can create a path for ground faults. To elaborate on the wiring inspection, pay close attention to the type of conductors used and their suitability for the environment. The use of type THHN copper conductors within conduit is generally acceptable. However, the transition to non-metallic sheath cable such as Romex in the attic requires careful consideration. Romex is typically not rated for direct burial or exposure to moisture and sunlight. While an attic might seem like a protected environment, temperature extremes and potential condensation can degrade the cable over time. The National Electrical Code, or NEC, provides guidelines for wiring methods based on environmental conditions. Section 300.3 discusses the suitability of conductors and cables. Regarding the grounding and bonding, ensure that all metallic components, including junction boxes and the EMT conduit, are properly bonded to the grounding electrode system. This provides a low impedance path for fault current to return to the source, facilitating the operation of the GFCI breaker. NEC Section 250.4 details grounding requirements. The use of a number 10 American wire gauge, or AUG, copper conductor for bonding is generally adequate for a 50 amp circuit. However, it's crucial to verify that the connections are tight and free of corrosion. When checking wire continuity, use a multimeter set to the ohms setting. Disconnect the power at the main panel before performing any continuity tests. Measure the resistance between each conductor and ground. A reading of 0 ohms indicates a direct short to ground, while a high resistance reading indicates an open circuit. Any reading other than infinite resistance between the hot conductors and the neutral or ground conductors indicates a potential problem. Remember, when testing for ground faults, a ground fault circuit interrupter tester is designed to inject a small amount of current to ground and verify that the GFCI breaker trips. If the breaker does not trip, it indicates that the GFCI is not functioning properly and needs to be replaced. When inspecting the SPA control panel, look for signs of water damage, corrosion, or burnt components. Pay close attention to the wiring connections, ensuring that they are tight and properly insulated. If you find any loose connections, tighten them securely. If you find any damaged components, replace them with like-for-like replacements. The heating element is a common source of GFCI tripping issues. Over time, the heating element can develop small cracks or pinholes, allowing current to leak to ground. To test the heating element, disconnect it from the SPA control panel and use a multimeter to measure its resistance. Compare the measured resistance to the manufacturer's specifications. A significantly lower resistance reading indicates a shorted heating element and it needs to be replaced. Also, check for continuity between the heating element terminals and the metal housing. There should be no continuity. If there is, the heating element is faulty. A clogged SPA filter restricts water flow, causing the heating element to overheat and potentially trip the GFCI. Regularly clean or replace the SPA filter according to the manufacturer's recommendation. Maintaining the proper water level is also essential for preventing GFCI tripping. If the water level is too low, the heating element may not be fully submerged, causing it to overheat. Ensure that the water level is at the recommended level, typically just above the jets. A damaged or poorly fitted SPA cover can allow moisture to enter the control panel, leading to electrical problems. Inspect the SPA cover for any cracks, tears, or gaps. Replace the cover if necessary. The junction boxes used in the installation must be properly sized and rated for the environment. Ensure that the junction boxes are large enough to accommodate all of the wiring connections without overcrowding. Overcrowding can lead to shorts and overheating. Additionally, the junction boxes must be rated for outdoor use if they are exposed to elements. Regarding the cord cap connection, ensure that it is securely connected to the SPA control panel and that the contacts are clean and free of corrosion. A loose or corroded connection can create resistance, leading to heat and potential GFCI tripping. The electrical metallic tubing, or IMT, conduit must be properly grounded to prevent ground loops. A ground loop occurs when there are multiple ground paths, creating unwanted current flow. To ground the ENT conduit, connect a grounding conductor from the conduit to the grounding electrode system at the main panel. Ensure that the conduit is properly connected to the junction boxes and the receptacle using grounding bushings. Inspect the receptacle for any signs of damage, such as cracks, burns, or loose terminals. Replace the receptacle if necessary. Also, ensure that the receptacle is properly grounded and that the grounding conductor is securely connected. The SO cord used to connect the SPA to the receptacle must be in good condition and free of any damage. Inspect the cord for any cuts, abrasions, or signs of overheating. Replace the cord if necessary. Additionally, ensure that the cord is properly sized for the current load of the SPA. A 50 amp circuit typically requires a number 6 AWG cord. In addition to the above troubleshooting steps, it's also important to consider the possibility of electromagnetic interference, or EMI. Electromagnetic interference can cause nuisance tripping of GFCI breakers. To minimize EMI, keep the SPA wiring as far away as possible from other electrical equipment, such as motors, transformers, and electronic devices. Use shielded cable for the SPA wiring if necessary. It is also crucial to adhere to all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides detailed requirements for the installation of spas and hot tubs. Consult with a qualified electrician to ensure that your spa installation meets all applicable code requirements. Proper documentation of the installation, including wiring diagrams and inspection reports, can be helpful for troubleshooting future problems. Keep a record of all maintenance and repairs performed on the spa, including the date, description of the work, and the name of the person who performed the work. This will help you track any recurring problems and identify potential trends. Remember, when working with electricity, always take safety precautions. Disconnect the power at the main panel before performing any troubleshooting or repairs. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician. When replacing components, always use like-for-like replacements that are approved for use in spas and hot tubs. Do not attempt to modify or alter the spa's electrical system in any way. This can create a safety hazard and void the warranty. Regularly inspect the spa and its electrical components for any signs of damage or wear. Address any problems promptly to prevent them from escalating. With careful troubleshooting and adherence to safety precautions, you can identify and resolve the cause of your spa's GFCI tripping issue. Remember to consult with a qualified electrician if you are not comfortable performing any of these tasks yourself. Always prioritize safety when working with electricity. If the GFCI breaker continues to trip after performing all of the above troubleshooting steps, it may indicate a more serious problem with the spa's electrical system. In this case, it is recommended to consult with a qualified electrician or spa repair technician. They have the expertise and equipment to diagnose and repair complex electrical problems. In some cases, the GFCI tripping may be caused by a combination of factors. For example, a small water leak in the control panel combined with a slightly degraded heating element could be enough to cause the GFCI to trip. In these situations, it may be necessary to address multiple issues to resolve the problem. When troubleshooting electrical problems, it is important to be patient and methodical. Do not rush through the troubleshooting process. Take your time and carefully inspect each component and connection. It is also helpful to keep a record of your troubleshooting steps and the results. This will help you track your progress and avoid repeating steps unnecessarily. If you are unsure about any aspect of the troubleshooting process, consult with a qualified electrician. They can provide guidance and assistance to help you resolve the problem safely and effectively. Remember, safety is always the top priority when working with electricity. Do not take any unnecessary risks. If you are not comfortable performing a particular task, consult with a qualified electrician. Regular maintenance is essential for preventing electrical problems in spas and hot tubs. Follow the manufacturer's recommendations for cleaning and maintaining your spa. This will help keep it running safely and efficiently for many years to come. Consider scheduling a professional inspection of your spa's electrical system every few years. This can help identify potential problems before they become serious. A qualified electrician can inspect the wiring, connections, and components and make any necessary repairs or adjustments. By taking these preventative measures, you can minimize the risk of GFCI tripping and other electrical problems. Regular maintenance and inspections can also help extend the life of your spa and ensure that it operates safely and efficiently. Remember, spas and hot tubs are complex electrical appliances. It is important to treat them with respect and follow all safety precautions. If you have any questions or concerns about your spa's electrical system, consult with a qualified electrician. They can provide expert advice and assistance to help you keep your spa running safely and efficiently. Finally, let's reiterate the importance of proper grounding and bonding. Grounding and bonding are essential for protecting people from electrical shock and preventing damage to equipment. Ensure that all metallic components of the spa, including the control panel, pump, and heater, are properly grounded to the grounding electrode system. This provides a low impedance path for fault current to return to the source, facilitating the operation of the GFCI breaker. Bonding is the process of connecting all metallic components together to create an equipotential plane. This helps to minimize the voltage difference between different parts of the SPA, reducing the risk of electrical shock. Use appropriately sized bonding conductors to connect all metallic components together. Consult with a qualified electrician to ensure that your SPA's grounding and bonding system meets all applicable code requirements.